Okay, everyone, let's talk about some material properties. So, our focus for this lesson and material properties is to talk about these four different types. There are a bunch of different ones, but these are the four that we want to focus on. So, we have surface area, that's the area around an object, mass, that's how much matter something contains, volume, how much an object can hold, and then density, and that's how dense something is. I know that that's pretty redundant, but we'll talk a little bit more about what density really is later. So, surface area. This is the areas of the outside of an object added together. So, when you think surface area, you can think wrapping a present. When you wrap a present, you wrap the outside of the present. You can also think of dropping the object in water. What does the water touch? That is your surface area. And if you look over here, you'll see these are equations for different types of surface area. Then when you calculate surface area, it really depends on what the object is. So let's look at this example with this square here, with this rectangular prism. So if you expanded this rectangular prism here and you created a net, so basically you had all of the sides laid out flat, it would create this model down here, and it labeled everything. So this is your front, this is the top, this is the back, this is the bottom, and then this is the right, that would be the left, and we can't see that. Now what we would do is we would take the area of each of these sections. So the front, top, back, bottom, left, and right. Okay, you can see it broken down over here. You just take the area of each one of these boxes to find the total surface area of 52 square units. Now volume. This is how much an object can hold within itself. So think filling a box with shaving cream. So anything inside. And you can think about when you're wrapping the box, the item that's actually inside of the box that you're wrapping. That's your volume. So the wrapping paper is the surface area. The gift inside is the volume. And then the water within a glass of water. All these are different examples of volume. And over here, you can see different equations for volume. Now, if you're calculating volume, it depends on the object, but in general, it is the area of the base times the height. So let's look at this box over here. We have the base right here. That's your width and your height. You multiply those together times this length right here. Multiply all this together and you get your volume. You can also see this as your base being the length and your width, and all that times your height. It really just depends on how you view your area, view your base. But as long as you have your base times your height, you'll get the correct thing. Now, again, we have all the equations back here, so you really shouldn't need to think about it too much, but you're always welcome to confirm with your teacher to make sure that you got the right equation and setup. So this, again, is how you would break it down. You'd multiply your length, width, and height. Now your mass. This is how much matter something has. This is not the same as weight. Weight is equal to your mass times gravity, because weight is a force and mass is just a quantity, it's a property. So mass is the amount of matter in something, and then weight is the gravitational pull on a mass. For example, this is something that I think of all the time. Your mass is how much matter you have. If you weighed yourself right now, let's say you're 100 pounds. If you weighed yourself in space, you would be less than 100 pounds because you don't have the same gravitational pull on your mass. So your mass would stay the same, but your weight would change if you went to space.